So how long does it take? So given the portion, how long will it take for the patient to get 55 milliliters of infusion? Okay, so start for what's given, 55 milliliters, right? So long is time, right? So somehow we're going to use our dosage rate and our volume to help us out, or one or the other. So how do we get rid of milliliters? Well, the only thing we have milliliters is our portion here. So we know for every 50 milliliters, there are 300 units. And now that's where we're going to use our dosage rate, right? So for every 3 units, we know there's 1 minute. And there we go. So cancel, cancel. So multiplying this should be 110 minutes it should take to go through 55 milliliters. Okay. And then B is very similar. So if you guys want to just quickly pause and try B, 3, 2, 1, pause, try it. Okay. So this one says calculate the number of units. So this is just the opposite, right? A patient will get in 30 minutes. So it's literally the opposite question of up here. As this one now, I gave you milliliters and wanted time. This one is I gave you time and I want, the unit itself. So literally just go in the opposite direction when it comes to this one. So you start with, the minutes. So therefore, we're going to go to this first. So it's minutes for every 3 units. And notice you're already done, right? We actually didn't have to use this portion because we didn't want milliliters. We just want units itself. However, if instead I wanted milliliters, that's what you have to go by. So you just another one, and you multiply it by this respectively, right? But since we want just units, you multiply it, it should give you 90 units altogether. Okay. All right, so that's that portion. So let's do the next page. So these are the next two when it comes to definition-wise what we care about. Okay? So next two definitions called a HEP lock or a saline lock and an IV push. So IV push is very interesting when it comes to medications. Okay? So first thing is called a HEP lock is an infusion port attached to the indwelling needle in a perspective vein, so an actual vein itself, right? And IV infusions can be administered through the ports from IV lines connected to the ports. Now, I give you on this page, I also have on canvas, you guys can see exactly how that would work out and see as well, both of the Hepling lock and an IV push, but IV push is pretty self-explanatory. IV push, or abbreviated is IVP for short, so be wary of PBIV, right? And then IVP mean two different things. Be very wary of the abbreviations. This is a direct a direct injection of medication either into the HEP lock or pushed, hence why it's called pushed, directly in the vein. So you're literally pushing it yourself when it comes to it. So that's what's called an IV push. Okay. So since IV push are administered manually, the speed at which the infusion is given is very important, which is key, right? You don't want to go too fast or too slow when it comes to the medication. So in order to minimize the error of speed, all IV pushes are mentally divided into segments or parts, which is the key thing, right? So for instance, if you had to give someone, some fluids over a minute, you want to just go a minute, you may just go every 10 seconds, right? Make it easy for yourself. So 10, 1, 2, 3, 4, 10, 1, 2, 3, break it down much easier and easy to count. You don't want to forget what your number is in the middle and you're like, oh crap, or what number was I on, right? So it makes it easier if you just break it down to simple functions. So here's a little example of what I mean by that. So for example, if you needed to give a patient 4 milliliters every second, you would just break it down to even smaller parts. So if you divide it by 2, that's 2 milliliters every 30 seconds. If you divide again, that's 1 milliliter every 15 seconds, which is much easier to see, right, and go by than just, 60 seconds is a long time to count, right? So if you do 1 milliliter, every 15 seconds, it minimizes the error involved when it comes to the whole portion itself. Okay, so here's a little example illustrating this kind of stuff as well. Okay, order says 800 milligrams of a drug, IP, so you're IV pushing, right, over 5 minutes, and the concentration of the drug is 80 milligrams per milliliter. Question A is find the number of milliliters you would administer. Okay, so we want milliliters, right? So our order is 800 milliliters, right? So we know it's 800 milligrams. Okay. Times, what's the only thing we know is, well, the flow rate. So it is for every 80 milligrams, there's 1 milliliter. Okay. So cancel, cancel, and this should be about 10 milliliters. Now, here's the key thing. Over 5 minutes, because that's going to be key or part B, in fact. You'll see why in a little bit. Okay, so that's 10 milliliters over 5 minutes. So you're technically going to give a total of 10 milliliters, okay, in that 5-period span. Now, B says find the flow rate if you divided the infusion into 5 equal segments. So remember, flow rate is volume over time. So 10 minutes over 5 minutes. Okay. And since we wanted 5 equal parts, you're going to divide the top and bottom by 5. So 10 divided by 5 is 2, and then 5 divided by 5 is 1. So essentially what you're saying is you're giving this patient 2 milliliters for every minute, so in 5 equal parts. So if it's at 3 equal parts, we would divide top and bottom by 3. If it's 10 equal parts, we divide top and bottom by 10. Does that make sense? And slowly break it down even smaller. Okay. All you want to do is make it easier for you to count when it comes to it. And most of the time, these are going to be in seconds. Very rarely anything above 15 is going to be the portion itself. Okay. So let's just try this out and give you guys more examples on this. Okay. So number 8 says the order is 250 milliliters, 5% of WW with 75 milligrams of a drug. And this is a lot of information given to us, right? So if you guys remember, this is 0.08 milligrams per kilogram per minute. So minutes and kilograms at the bottom. Okay. IV push daily. The patient was 80 kilograms with a drop factor. So they gave us a drop factor. So somehow we're going to be using our drop factor. Okay. Calculate the flow rate for this drug in drops per minute. So we want GTT per minute, right? We want the drop factor itself, right? Okay, so let's do. The only thing we can think of is the weight, right? It's the only thing that's not pretty much given to us. That's the only patient weight itself. So let's just start with 80 kilograms. All right, so we give it a lot of information. So what's the only thing that cancels out the kilograms is this drug portion, right? So they give us 0.08 milligrams per kilogram per minute. So we know since we want kilograms at the bottom, it's going to be like that. And then also minutes is going to be at the bottom. So we have that going. So that gets rid of milligrams. And notice we already have minutes, which is great, right? We have minutes and our answer already. So now all we have to do is convert the milligrams into drops, and we're done with that portion. All right, so the next thing is, well, what's the only thing we're going to use that gets rid of milligrams? Well, let's see. Well, noticing the order. Well, actually, I can multiply this out, make it easier. This gives us 6.4 milligrams per minute. Okay, so now I'm going to multiply by that portion. Okay, so if we multiply this portion, well, remember it's 250 milliliters for every 75 milligrams, so milliliters has to go on top to get rid of the milligrams at the bottom. So this is 75, and this is the 250 on top. And then finally, we use our drop factor. For every 1 milliliter, we know there are 20 droplets. So finally, canceling all of this stuff out, we get our answer, or should get an answer, roughly 426.7 drops per minute. And there we go. Okay. Right. And the last question, next example for this chapter is order 5 milligrams per kilogram per minute. So hopefully it's the same process, right? 5 mg per kg in the minute at the bottom. Very similar to the top we did on the top one. If a patient weighs 100 kilograms, A, find how many milligrams per minute should be administered. So why don't you guys try these questions out, A and B. So quickly, just pause it. 3, 2, 1, pause. Okay, so hopefully you guys tried them. So A, how many milligrams per minute should be administered? So we want mg per minute. So somewhere we're going to be using this and our patient weight, right? So start with a patient weight. And notice we actually don't have to do that much work, because if we multiply literally by that, the kilograms cancel, and we have mg per minute. So this would be 500 milligrams per minute. No, that's not too bad, right? The last thing is how long. So we're looking for time, right? So how long will the patient receive 60 milligrams of this drug? So we're looking for time somehow, right? So start with what's given to us, 60 milligrams. Well, the only thing we know that cancels out milligrams is, again, the order itself. So this one now has to go on the bottom. Now, The cool thing is you can actually use this, or you can use what you have here, right? Because we're only looking for time. So you can actually already do this and give it down here. If you don't, you actually still have to use the weight of the patient to cancel the kilograms, but since we have this already done, we can use that and get that portion. We just skip one simple step there. So if you do this, we should get 0.12 minutes, or approximately 7.2 seconds, just in case you guys want to interested why that portion is itself. Okay, so that's chapter 11. Pretty much roughly the same as, hopefully you guys notice, it's the same process. Nothing really brand new. Dosage rate, all it is drug over time, but notice it's the exact same template we've been doing all this portion as well.